Honda wants safety not just for people riding in cars and on motorcycles, but for all people using the roads. With safety for everyone as our slogan, we aim to realize a society where people do not have accidents. Honda has been making products from technologies for preventive safety and for mitigating the burden on the customer for 10 years or more. These include the Lane Keep Assist System, LKAS in 2002, and the Collision Mitigation Braking System, CMS, in 2003. Currently, Honda has developed a new system that is made up of two types of sensors with different characteristics: a monocular camera positioned at the top of the windshield and millimeter wave radar inside the front grille. By combining the dual strengths of the radar in object detection and the camera in object recognition, the system can achieve recognition with even greater accuracy. Honda's advanced driver assistive system uses information from radar, cameras, and other sensors to provide assistance with driving and support for accident prevention. Together, these systems comprise Honda Sensing. Let's look at the 6 new Honda Sensing functions. The Collision Mitigation Braking System detects preceding vehicles, pedestrians, and oncoming vehicles. Then the system assists to avoid collision. When there is a risk of a collision, the system works to reduce the impact and mitigate the damage by applying automatic braking. The camera recognizes the attributes and size of an object. The millimeter wave radar detects the location and speed of the object. The system provides audio and visual warnings as well as haptic tactile to facilitate the driver's collision avoidance actions. If collision with an oncoming vehicle is likely, the system similarly uses sound, displays, and haptic warnings to prompt the driver to take avoidance maneuver. If avoidance maneuver is not taken in time and collision is unavoidable, the system automatically activates the brakes to reduce the impact speed and mitigate damage. The false start prevention function uses the millimeter wave radar while stopped to check if there are any preceding vehicles. When a vehicle is detected, the system prevents sudden acceleration when the accelerator is pressed hard and alerting the driver with a warning sound and display warning. The road departure mitigation system uses a camera to detect the lane markers. If the car verges on crossing a lane marker, the system provides vibrations on the steering wheel to alert the driver and provides steering assistance. When the car goes too far over a lane marker, the system applies the brakes to help keep the car from leaving the road. The pedestrian collision mitigation steering system uses a monocular camera and millimeter wave radar to detect pedestrians. When the system predicts dangers such as potential collisions, it alerts the driver with an audible alarm and applies corrective steering input to avoid collision. Adaptive cruise control with low-speed follow reduces the driving burden involved in highway driving. It detects the distance from the preceding vehicle and the difference in speed between the vehicles, automatically controlling braking and acceleration to maintain an appropriate distance. When the vehicle is stopped, low-speed following is resumed at the touch of a switch or by pressing the accelerator when the preceding vehicle begins moving. The Lane Keeping Assist system reduces the driving burden involved in highway driving. It uses a camera to detect lane markers, providing steering assistance to make it easy to keep the vehicle in the middle of the lane. The lead car departure notification system uses millimeter wave radar to detect when a stopped vehicle in front of the driver starts moving, and alerts the driver with a sound and display indication. The traffic sign recognition function uses a camera to detect traffic signs, displaying information on the multi-information display to alert the driver and support safer driving.